Lesson 80, Conservation Momentum Examples. Two cars moving in opposite directions collide and move off stuck to one another. Car A is 55 kilograms, traveling with a velocity of 6.7 meters per second to the right. Car B is 70 kilograms, moving to the left with a velocity of 7.3 meters per second. What is the speed of the combined cars after the collision? Before the collision, the initial momentum for car A is mass of car A times initial velocity of car A, which is 55 times 6.7. The initial momentum for car A is 368.5 kilogram meters per second. The initial momentum for car B is mass of car B times initial velocity of car B, which is 70 times negative 7.3. Note the negative sign, as they are moving in opposite directions. The initial momentum for car B is negative 511 kilograms meters per second. The initial total momentum is the initial momentum of car A plus initial momentum of car B, which is 368 plus negative 511. The initial total momentum is negative 142.5 kilogram meters per second. After the collision, the final total momentum will also be negative 142.5 kilogram meters per second due to the law of conservation of momentum, which states that momentum cannot be gained or lost. Final total momentum is equal to final momentum of car A plus final momentum of car B. This is mass of car A plus mass of car B times final velocity. Negative 142.5 equals 55 kilograms plus 70 kilograms times velocity final. Velocity final is negative 142.5 divided by 125 kilograms. The final velocity of the two cars moving off together is negative 1.14 meters per second, or 1.14 meters per second to the left. Example number 2. Car A rear ends car B. Car A is 27 kilograms and travels at plus 8.2 meters per second, while car B is 34 kilograms, traveling in the same direction at 4.5 meters per second. In this case, the cars do not stick after the collision, rather they collide and bounce. If car A travels at velocity of plus 3.1 meters per second after the collision, what is car B's velocity? The initial momentum for car A is 27 times positive 8.2, which makes 212.4 kilograms meters per second. The initial momentum for car B is 34 times positive 4.5. Note the positive sign as they're moving in the same direction, which makes 153 kilogram meters per second. The initial total momentum is 221.4 plus 153. The total is 374.4 kilogram meters per second. After the collision, the final momentum must be the same value based on the law of conservation of momentum. Total final momentum is 374.4 kilogram meters per second. Total final momentum is final momentum of car A plus final momentum of car B, which is mass A times final velocity of A plus mass B times final velocity of B. 374.4 kilogram meters per second equals 27 times 3.1 plus 34 times the final velocity of B. 374.4 equals 83.7 plus 34 times V. 34 times V equals 374.4 minus 83.7. 34V equals 290.7 kilogram meters per second. Velocity final for B is 290.7 divided by 34, which is 8.55 meters per second. Example 3 has a 50 kilogram student standing on a stationary skateboard who tosses the 8.4 kilogram medicine ball forwards at a rate of 3.1 meters per second. What velocity does the student recoil at? Assume ideal conditions. The initial momentum will be 0, since the velocities are 0. After the toss, the total momentum will still be 0, due to law of conservation of momentum. The final total momentum is the sum of final momentums, which is the final momentum of student plus the final momentum of the medicine ball. The final momentum total is mass of the student times the velocity of the student plus the mass of the medicine ball times the velocity of the medicine ball. 0 equals 50 times velocity plus 8.4 times 3.1. 0 equals 50 times the velocity plus 26. Negative 26 equals 50 times velocity. Velocity equals negative 26 divided by 50. The final velocity of the student would be negative 0.52 meters per second.